When assessing the capacity of an existing electrical service for expansion, several key steps must be taken. Firstly, determine the total amperage demand of the existing services. In this scenario, there are 3 existing 200 amp services, which equates to a total of 600 amps. Add the proposed new 200 amp service to the existing load, resulting in a total of 800 amps. Secondly, identify the size of the feeder wire currently supplying the existing services. This can often be determined by examining the rating of the main breaker located in the electrical panel, typically found in the same panel as the meters. The main breaker rating provides an indication of the feeder wire's capacity. Once the feeder wire size is known, compare its ampacity to the total amperage demand of both the existing and proposed services. It's crucial that the feeder wire is adequately sized to handle the combined load of all services it supplies. An assumption in the original assessment suggests the existing feeder wire is a 400 amp wire. Verify this by physically inspecting the wire size and referencing appropriate ampacity tables in the National Electrical Code, specifically Table 310.15b16 or similar tables applicable to the specific wiring method used. If the existing feeder is indeed a 400 amp wire, then this is less than the 800 amps now required, so this needs to be upgraded. When determining the appropriate size for the new feeder wire, several factors must be considered beyond just the calculated load. Firstly, apply any applicable demand factors as permitted by the National Electrical Code. Demand factors allow for reductions in the calculated load based on the understanding that not all connected loads will operate simultaneously at their maximum rating. Article 220 of the National Electrical Code provides guidance on applying demand factors for various types of occupancies and loads. Secondly, consider voltage drop. Excessive voltage drop can negatively impact the performance of electrical equipment. The National Electrical Code recommends limiting voltage drop to 3% for feeders and 5% overall, including both feeders and branch circuits. Calculate the expected voltage drop based on the feeder wire size, length, and the anticipated load. Increase the wire size if necessary to maintain voltage drop within acceptable limits. Thirdly, account for ambient temperature and conductor bundling. The ampacity of conductors decreases as ambient temperature increases and when multiple conductors are bundled together. Apply correction factors and adjustment factors as specified in the National Electrical Code to ensure the selected wire size can safely carry the required current under the anticipated operating conditions. Also, consider future expansion. It may be prudent to select a wire size that provides some extra capacity to accommodate potential future load increases, avoiding the need for costly upgrades later on. Finally, ensure the selected wire type and insulation are suitable for the installation environment, considering factors such as moisture, temperature, and exposure to chemicals. Once the appropriate feeder wire size has been determined, ensure that the overcurrent protection device, such as a circuit breaker or fuses, is properly sized to protect the feeder wire. The overcurrent protection device should have an ampacity no larger than the ampacity of the feeder wire it protects, as specified in the National Electrical Code. Next, assess the physical space available in the existing trough to accommodate the new service. The proposed 200 amp service will require space for a 200 amp circuit breaker and the associated wiring. Estimate the space required for the circuit breaker based on its physical dimensions. Consider the bending radius and routing requirements for the 200 amp wire to ensure it can be installed safely and without exceeding the trough's full capacity. National Electrical Code Section 314.28 provides requirements for conductor bending space at terminals and input boxes, junction boxes, and conduit bodies. These requirements are essential to ensure safe and reliable connections. Consider the physical dimensions of the conductors being used. Conductors come in various sizes and types, each with different insulation thicknesses and overall diameters. Consult the conductor manufacturer's specifications to determine the exact dimensions of the conductors you plan to use. Ensure that the trough is not already overcrowded with existing wiring. Overfilled troughs can lead to overheating, difficulty in making connections, and potential safety hazards. If the trough is already crowded, explore options for expanding the trough or installing a separate trough for the new service. Examine the condition of the existing trough. Look for signs of corrosion, damage, or deterioration. Replace the trough if it is not in good condition, because a damaged trough can compromise the safety and reliability of the electrical system. If the existing trough is metallic, ensure that it is properly grounded and bonded to the electrical system. Proper grounding and bonding are essential for preventing electrical shock hazards. National Electrical Code Article 250 provides detailed requirements for grounding and bonding electrical systems. Based on the original assessment, there are 4 spaces available in the trough which is deemed sufficient for the new service. Verify these measurements. Before proceeding with any work, it is crucial to have a qualified electrician verify all findings and calculations. A qualified electrician can perform a thorough inspection of the existing electrical system, conduct load calculations, and ensure that all work is performed in accordance with the National Electrical Code and local electrical codes. The National Electrical Code is a comprehensive set of standards for the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. Local electrical codes may also have additional requirements that must be followed. Verify that the existing electrical service is properly grounded and bonded. Grounding and bonding are essential for providing a safe path for fault current to return to the source, minimizing the risk of electrical shock. Inspect the grounding electrode system, including the grounding electroconductor, ground rods, and any other grounding electrodes. Ensure that all connections are tight and corrosion-free. Verify that the bonding jumpers are properly sized and installed to bond all metal enclosures, raceways, and equipment. Check that the main bonding jumper is properly connected between the neutral bus and the equipment grounding bus in the main service panel. Ensure that all branch circuits are properly identified and labeled. Accurate labeling is essential for facilitating troubleshooting and maintenance. Verify that the overcurrent protection devices are properly sized and coordinated to protect the branch circuits and equipment. Perform a voltage drop calculation to ensure that the voltage at the furthest point of each branch circuit is within acceptable limits. Measure the voltage at various points throughout the electrical system to verify that the voltage is stable and within the specified range. Check for any signs of overloading, such as hotspots, flickering lights, or trip circuit breakers. Investigate and correct any overloading issues before adding additional load to the system. Inspect the electrical panel for any signs of damage, corrosion, or overheating. Replace the panel if it is not in good condition. Verify that all electrical connections are tight and secure. Loose connections can cause overheating, arcing, and potential fire hazards. Use a torque wrench to tighten connections to the manufacturer's specifications. Check for any exposed wiring or damaged insulation. Repair or replace any damaged wiring or insulation to prevent electrical shock hazards. Ensure that all electrical boxes and enclosures are properly covered and secured. Uncovered boxes and enclosures can expose live electrical parts, creating a safety hazard. Test all ground fault circuit interrupter receptacles to ensure that they are functioning properly. Ground fault circuit interrupters are designed to protect against electrical shock hazards in wet or damp locations. Verify that all smoke detectors and carbon monoxide detectors are functioning properly. Smoke detectors and carbon monoxide detectors are essential for protecting against fire and carbon monoxide poisoning. Ensure that all emergency lighting and exit signs are functioning properly. Emergency lighting and exit signs are essential for providing illumination and guidance during power outages. Provide training to employees on electrical safety practices. Employees should be trained to recognize electrical hazards and to take appropriate precautions to prevent electrical accidents. Document all electrical inspections, tests, and repairs. Maintaining accurate records is essential for tracking the condition of the electrical system and for complying with regulatory requirements. Consider using a thermal imaging camera to identify hot spots in the electrical system. Thermal imaging cameras can detect areas of excessive heat, which may indicate loose connections, overloaded circuits, or other problems. Develop a written electrical safety program. An electrical safety program should outline the procedures for safely operating and maintaining the electrical system. Review and update the electrical safety program regularly to ensure that it is up to date and effective. Conduct regular safety meetings with employees to discuss electrical safety issues. Safety meetings can help to raise awareness of electrical hazards and to promote a culture of safety. Encourage employees to report any electrical hazards or concerns to management. Prompt reporting of hazards can help to prevent accidents and injuries. Conduct regular audits of the electrical system to ensure that it is in compliance with all applicable codes and standards. Electrical audits can help to identify potential problems and to ensure that the electrical system is operating safely and efficiently. Work with a qualified electrical contractor to perform any necessary repairs or upgrades to the electrical system. A qualified electrical contractor has the knowledge and experience to perform electrical work safely and effectively. Follow all lockout/tagout procedures when working on electrical equipment. Lockout/tagout procedures are designed to prevent accidental energization of electrical equipment during maintenance or repair. Use appropriate personal protective equipment when working on electrical equipment. Personal protective equipment, such as gloves, safety glasses, and insulated tools, can help to protect against electrical shock and other hazards. Be aware of the potential hazards of working near energized electrical equipment. Maintain a safe distance from energized equipment and use caution when working in areas where electrical hazards may be present. Never work on electrical equipment when you are tired or distracted. Fatigue and distraction can increase the risk of electrical accidents. If you are not qualified to perform electrical work, do not attempt to do so. Electrical work should only be performed by qualified individuals who have the necessary training and experience. National Electrical Code Section 110.3b requires that all electrical equipment be installed and used in accordance with its listing and labeling. This means that you should carefully follow the manufacturer's instructions for installing and operating electrical equipment. Failure to follow the manufacturer's instructions can void the warranty and may create a safety hazard. National Electrical Code Section 110.12 requires that all electrical work be performed in a neat and workmanlike manner. This means that the work should be done carefully and professionally with attention to detail. Sloppy or unprofessional work can create safety hazards and may not meet the requirements of the electrical code. National Electrical Code Section 300.4 requires that all wiring methods be properly supported and secured. This means that the wiring should be supported in a way that prevents it from sagging, rubbing, or being damaged. Proper support is essential for ensuring the long-term reliability of the electrical system. The ambient temperature around electrical conductors affects their ampacity. Higher temperatures reduce ampacity. Correction factors found in NEC Table 310.15 must be applied. Conductors bundled together also have reduced ampacity. Adjustment factors per NEC Table 310.15 must be applied. Aluminum conductors have different ampacities than copper conductors. Always refer to the appropriate ampacity table based on the conductor material. Using the wrong conductor size can lead to overheating and fire. Heated taps are allowed under certain conditions specified in NEC Section 240.21b. Always follow the requirements for tap conductors, including length limitations and overcurrent protection. Surge protection devices (SPD) can help protect sensitive electronic equipment from voltage surges. Consider installing SPD at the service entrance and at downstream panels. The NEC requires arc fault circuit interrupter PSI protection for branch circuits supplying certain locations. Check the NEC for the latest requirements for PSI protection. Ground fault circuit interrupter GFCI protection is required for receptacles in certain locations, such as bathrooms, kitchens, and outdoor areas. The NEC specifies the locations where GFCI protection is required. Electrical panels must have adequate working clearance as specified in NEC section 110.26. Maintain clear access to electrical panels for inspection and maintenance. Electrical equipment must be properly labeled to indicate its function and voltage. Clear labeling helps prevent confusion and errors during maintenance and troubleshooting. Ensure that all unused openings in electrical panels and boxes are closed with appropriate covers or plugs. Openings can allow dust, moisture, and pests to enter, which can damage electrical equipment. Use only approved electrical components and equipment. Approved equipment has been tested and certified by a recognized testing laboratory, such as Underwriters Laboratories UL. Never use counterfeit or unimproved electrical equipment. Regularly inspect electrical cords and plugs for damage. Replace any damaged cords or plugs to prevent electrical shock hazards. Do not overload electrical circuits. Overloading can cause the wires to overheat and potentially start a fire. Use a power strip with a built-in circuit breaker to protect against overloading. Unplug electrical appliances when they are not in use. Unplugging appliances saves energy and reduces the risk of electrical shock. Keep electrical appliances away from water. Water can conduct electricity and create a shock hazard. Never use electrical appliances in the bathtub or shower. Do not run electrical cords under rugs or carpets. Cords under rugs or carpets can overheat and potentially start a fire. Keep electrical cords away from heat sources. Heat can damage the insulation on electrical cords and create a shock hazard. Do not attempt to repair electrical appliances yourself unless you are a qualified electrician. Electrical repair should only be performed by qualified individuals who have the necessary training and experience. If you experience an electrical shock, seek medical attention immediately. Electrical shocks can cause serious injuries or even death. Call 911 in the event of an electrical emergency. Be prepared to provide the dispatcher with your location and a description of the emergency. Stay away from downed power lines. Downed power lines can be extremely dangerous and can cause serious injuries or death. Report downed power lines to the power company immediately. Know the location of the main electrical panel in your home or building. Knowing the location of the main panel will allow you to quickly shut off the power in the event of an emergency. Have a qualified electrician inspect your electrical system periodically. Regular inspections can help to identify potential problems and to ensure that your electrical system is operating safely and efficiently. Consider upgrading your electrical panel if it is old or outdated. Older panels may not be able to handle the demands of modern appliances and electronics. Educate your family about electrical safety. Teaching your family about electrical safety can help to prevent accidents and injuries. Make sure that everyone in your family knows how to shut off the power in the event of an emergency. Post emergency contact information near the main electrical panel. Emergency contact information should include the phone numbers for the power company, the fire department, and a qualified electrician. By following these electrical safety tips, you can help to protect yourself and your family from electrical hazards. Remember, electrical safety is everyone's responsibility.